Hello everyone, I hope you all are doing great. My name is Dheeraj Choudhary and welcome back to our Python for Machine Learning and Artificial Intelligence series. In this video, we are diving into lists, which is one of the Python's most powerful and flexible data types. You will learn how to create lists, access lists, update values, perform key operations like slicing, appending, removing, and more. So lists are used everywhere in Python, from looping over to storing predictions in machine learning models. If you are ready to master list, drop a comment saying list unlocked. I want to know who is coding along with me. So stick around till the end. By the end we are done, you will be handling Python list like a pro and building strong foundations for your AI journey. So without wasting much time, let's get started. Welcome to our fifth video in our Python for Artificial Intelligence and Machine Learning series. Today we will explore Python list, one of the most versatile and commonly used data structure that will be essential for our artificial intelligence and machine learning journey. List allows us to store collections of data, which is critical when working with datasets and features like vectors in AI application. So let's understand what is list. So lists are fundamental data structures in Python that store ordered collection of items. So unlike some languages that require all elements to be same time, Python list can contain any mix of data types. So over here, if you see, so usually if you see in other languages, when I am going to define an array or a kind of list, all has to be integers, right? Or all has to be string. So it has to have one data type inside the list that we are creating. But in Python, it is different. So in Python, I can also create a mixed data type list. So over here, you can see I am having string, I am having integer, I am having boolean, and I am having float, all data types together. So this flexibility makes them perfect for representing various data in AI applications. And lists are mutable. It is not like strings. So strings are immutable, but lists are mutable, meaning you can change their content after creation, which is essential when pre-processing data for machine learning. Let's jump to our coding screen and see what are these different kinds of lists that I was talking about. So over here, so if I say print, so if I'm going to first create a list with numbers, it is going to save that, and it is also going to print that for us. See 1, 2, 3, 4, 5. Now the same way, if I'm going to do it with different data types, it is again allowed. It is not going to give any error. So that is how you can create list in Python. Now let's go ahead and understand how we can create different types of Python list. So there are multiple ways to create list in Python. You can initialize an empty string like this, my list is equal to empty string. Then you can create a one with the predefined values. So over here, the values are being predefined. You can convert other sequences like range into a list. So over here, we are creating a string by giving a function itself. We are saying list range 1 to 6. So it is going to create a list with the values of a range 1 to 6. Or you can use list comprehensions. So this is a list comprehension. You can also use a list comprehension to create the values of the list that you want to create. And list comprehensions provide an elegant way to create list based on existing list, which is incredibly useful when transforming data for machine learning algorithms. Nested lists allows us to create multi-dimensional structures. We will see that later when we are going to go in NumPy and Pandas, how this multi-dimensional structures are going to help us in the when we are going to use matrices. So that is how nested list comes into picture later on. So nested list allows us to create multi-dimensional structures similar to matrices or tensors used in AI application. Now, whatever we have seen over here, let's go ahead and see how it is over here. So over here, if I see my list, this is going to give, I have saved the empty list, and if I print, you will see this is the empty list. Over here, these are with the predefined values. The values are defined. So this is the list that is printed. Now, if I say list create from a range 1 to 6, that is going to be, it will start with 1, but it is not going to end at 6. It is going to be 6 minus 1. whenever you are going to use the range. So that's why it has printed 1 2 3 4 5. You should be aware of that. List comprehensions to generate squares. So what it is doing is, within a range of 1 to 5, it is doing an exponential where x. So for example, for x is range 1 to 6. So for x, so x will start with 1. At that time, x star 2, it is going to be 1 into 1. Then after 1, it is going to be the next one, that is 4. It is going to be 2. So 2 into 2, 4. 3 into 3, 9. 4 into 4, 16. 5 into 5, 25. So whatever you see over here which was printed, whenever it came to x, it has taken the exponential, and based on that it has printed the value over here. This is how you use list comprehension. Now nested list. So in nested list, what you can do is you can create multiple list within one list. So in this, there are 3 different lists which are part of one list. Okay, this is in a matrix format, where you just think of it as a matrix where we have 3 rows. This is row 1, row 2, and row 3. So these are the 3 different values in 3 different rows of a matrix that we have defined. Now let's go ahead and move next. So how to access the list elements? Elements are, so if you see apple, banana, cherry, date, elderberry, these are the elements. So these are known as the elements within the list. Okay, so accessing element is a list is done through indexing. Remember that Python uses 0 based indexing. We have seen that in string also. It starts with 0, meaning the first element is at index 0. Negative indices provides a convenient way to access elements from the end of the list, the same way that we saw in string. When you start with -1, it will start, instead of starting when we say 0, it will start with apple. When we say -1, it will start with elderberry. Slicing allows you to extract a portion of a list with a syntax list like start, end, and step, that we will see very soon in our code. So where start is inclusive and end is exclusive. Again, so if we are going to do it with this, so right now if I say fruits 1:4, so it will start with the index of 1, but it is not going to end with the index of 3. It is going to be 4 minus 1. That's what I am trying to say. So when working with datasets in machine learning, you will often need to access specific features or sample, making these techniques essential for your machine learning journey. Now let's go ahead and look at all these list elements. Okay, indexing starts at 0. How? Let's see that. So when I say print numbers 0, so first of all, the list value has been stored in numbers, and when I say print number, that is a variable name, and whatever element is available at 0th location. So it gave the output as 10. When I say 2, it is going to be 0, 1, and 2. That's why it gave 30. That is how the indexing works in list. Now negative indices count from the end. Okay, yes, sorry about that. Where is now negative indices count from the end. So when I say print numbers -1, so instead of starting from 10, it is going to start from 50. -1 means 50. Then we say numbers -3. What is -3? -1, -2, -3, 30. That is how it has been calculated when you come from right to left. Now slice from index 1 to 4, excluding 4. As I said, when I say print numbers 1:4, it will start with 1, but it is not going to end with 4. It is going to be 4 minus 1. That means it is going to be printing 1, 2, 3, starting with 1. So that's why when you see the list over here, so this is 0, right? This is 1. So it is going to print over here is 20, 30, 40. That is 1, 2, and 3. It is not going to print 4, because by default it is excluding the last one. Slice with step 2. This we have already seen in string. Again we will see. So this is the format of slicing with steps, where this is the start, 0 is the start, 5 is the end, and 2 is the step. What does that mean? So we start from 0, that means 10. Okay, so it says that you start from 0 and till end to 4. This is 0, 1, 2, 3, 4. That is 5 minus 1 is going to be 4. So we will start from 10, we will end till 50. So this is what start and end signifies. Now what step 2 says that you will start from 0. So after 0, you will skip 1 and you will move to the next one. So after 0, you have to print 2. Then you have to print 3. Then you have to print 5. So you have to skip 1 and move to the next one. That is how it has printed the value. It started with 10, then it jumped to 30, then it jumped to 50. Now reverse the list using slicing. So to reverse, what you have to do is colon minus 1. It is going to reverse the entire string. So right now it is 10 to 50. Now it has become 50 to 10. You can see over here. Now accessing index beyond the list size causes an error. You should be aware of it. Suppose if I say print numbers 10, there is no value, no element present at number 10. And if you use this kind of code, it is going to give you an error. So you should be mindful of using this kind of code. Now, let's see what's next. So now we are going to see how we can modify our list. So one of the key advantages of list is their mutability. You can modify them after creation. You can change individual elements by reassigning values, add elements using append or insert, combine list with extend, and remove elements using delete or remove method. These operations are crucial when pre-processing data for machine learning models, where you might need to add new features, remove outliers, or transform your data set in various ways. I know these are the jargons that you're not yet aware of, but in our machine learning journey, very soon we will cover this also. So let's understand this code by code. So modifying list, I will go ahead and open this, reassign a value at a specific index. So what we are going to do is, we are going to say our my list is 10 to 30, 10, 20, 30. Now my list 1 is equal to new value. What we are doing is, we are saying at the index of 1 instead of 20. So 20 is at 1. I don't want to keep it 20. I want to replace it with a string that is new value. That is what reassigning a value at a specific index means. So over here you saw 10 is as it is, 30 is as it is, and this value has been replaced, and the string has been, and the list has been modified. Sorry about saying the string. Now append a new item to the end of the list. So in this, what we are saying, so whenever we use dot append, it is going to append an item at the end only. It is not going to append it anywhere. So when I say dot append 40, it is going to append at the end. So now this is our new string, okay? And when I say append 40, it has added 40 after this existing string that we have. That is how append method works. Now insert an item at a specific index. So when you have to insert an item as a specific index, what you can do is, you can go ahead and use insert method, where you say the index is 1, and so at place of 1, you have to go ahead and change the specific element. So over here 0, 1. So right now 1 is new value. You have to change that with new new string value that is inserted. And when you print it, you will see that 10. Okay. So my bad over here. Inserting is, you are just going to insert a value. It is not going to replace the value. So when I am going to say that I am going to insert a value at 1, so it is going to get inside that position, and the values which were existing on their location, they are going to shift on the right side. So over here at if you see, this is 0, 1, 2, and 3. Now when I am inserting this, what happened? This becomes 0, this became 1, and which this shifted. So the element indexes has been shifted for them. So this is how insert works, where you can insert elements and the following values are aligned appropriately. Okay. Extend the list with another list. So suppose if you want to extend your list with another list, what you can do is, you can use dot extend method. So dot extend method helps you extend your list with another list that is available. So it is not going to create another different list. It is merging actually the list that you have passed into this list from the end. So it is not going to start from 0. It is going to add at the end. Remove an item by index using delete. So when I say delete my list 2, what it is going to do is it is going to go ahead and whatever is available at the index of 2, it is going to delete that, and the values which are on other indexes after that will get arranged accordingly. So right now it is 0, 1, 2, 3, 4, 5, 6. So 30 is 3, 4, 5, 6. Now 30 became, from 30 it is 2, 3, 4, 5. So it arranges accordingly once the element is been removed. Now remove an item by a value. So till now we were removing the item based on the indexes. Now we are going ahead and removing it based on the value. So remove an item by value. So my list dot remove 40. So it will search for a value of 40 and it is going to remove that from the list. So that is removing by value. Clear all elements from the list. When you want to remove all the elements from your existing list, you can just say my list dot clear and it is going to make your list empty. Now let's see what's next. Next, we are going to talk about essential list methods. Python provides numerous built-in methods for working with list. So these methods allow you to manipulate list efficiency without writing complex loops. For example, sort is essential when you need to order your data. Count helps identify frequency, and pop can be useful for implementing algorithms like stack. So in machine learning, you might use these methods when cleaning data, handling missing values, or preparing features for your models. So let's go ahead and see that on our screen over here, coding screen. So append item, add an item to the end of the list. So as I said, by default, whenever you use append, it is going to add it at the end of your list. Remove item. So by using remove keyword, you can go ahead and remove an item from a specific index. Now pop index removes and return items. Default is the last. So when you say last item is equal to my list dot pop, so by default it is going to pop out the last value, that is the last value is 4 over here, and it is going to return that to your specific variable that in which you are calling that. So over here when I say list is equal to my list dot pop, it has returned 4 to last item and it has been saved in last item. So print last item is equal to 4 now, and print my list. So it has been removed from here and it has been given it to the variable last item. Now index item, find the index of first occurrence. So over here when what we are doing, I think my list index inserted. Okay, so again you will get this kind of value error. This is for your information. Whenever you are going to try something on a specific index which is not available, it is going to give you an error over here. So inserted is not in the list, so it is giving you a value error and it is telling you that it is not part of the list. Now let's go ahead and run the other one. Count item, count how many times an item appears. So my list dot append 3, print my list dot count 3. So right now, first what I will do, first I will print the list for you so that you know what exactly the value was in my list, so that you will understand. Okay, so 1333 is available. Okay, after that when we say my list dot append, 3 is been appended over here. Okay, my list dot append, so it becomes 1333. And then when I say print my list dot count, so after appending 3, the output becomes 4 because we have appended that 2 times. That's the reason. Now sort the list in place. So over here right now the numbers are not in a sorted manner, 5 2 8 1. If we have to sort the elements, we can directly say numbers dot sort and we can print. So when I say numbers dot sort and print, so instead of 5 2 8 1, it became 1 2 5 8. It has been sorted now from ascending to descending. Reverse. So if you have to reverse the list in place, what you can do is you can go ahead and run numbers dot reverse. It will reverse the string. So it was 1 2 5 8. Now it is 8 5 2 1. It has been reversed. Copy. It creates a shallow copy of the list. So what you have to do is list is mutable. So whatever changes you are doing, it has been saved in that specific list only. But in strings, if you do any changes, it is not been saved because it is immutable. So when you don't want your list to be changed for the operations that you are performing, you can create a shallow copy of it. That means you can create a copy of the value of that list and store it on some other location. Okay, so for that you can use dot copy. You can use copy method, which is going to copy the value of the existing list and save it onto a different memory location and return it. Now let's see what's next. So iterating through list. So iterating through list is a fundamental operation in data pre-processing. So Python offers several ways to loop through list. The most common is to use for each style loop, which directly accesses each element. When you need both the element and its position, the enumerator function is invaluable. So list comprehensions provide a concise way to apply transformation to every element. In machine learning workflows, you will constantly iterate through data points to compute statistics, apply transformations, or evaluate model performances. Now, let's see how this iteration through list works with few examples. So I will just go ahead and show you. So my list is equal to AI, ML, and DL. So what I'm going to do is I have to print each and every element one by one. So in that case, what I have done is I'm using a for loop for item in my list. So for item in my list, and I say print item. So when this for loop starts, it will start from 0. So the first item in my list is going to be AI. Print item, AI is printed. Print item, ML is printed. Print item, DL is printed. This is how you can use loop to access each element of your list directly. Now enumeration, access both index and item. So for index, item in enumeration, my list, print index and the item number. So by using enumeration, what you can do is you can print the value as well as the index location of that specific element that you have saved in the list. Now list comprehensions. So in list comprehensions, you create a new list from an existing one. So what I'm going to do is over here is uppercase is equal to item dot upper. So all the items within the list is going to be changed from lowercase to uppercase, and it is going to be saved into uppercase, a new variable. That means a new list is going to be created and it is going to be returned to this variable uppercase, and uppercase is going to save that new list as part of the uppercase that we have used. Now using indices, access items by index. So few minutes before, what we were doing is we were directly printing it. So by default it was going ahead and doing it from left to right. But many a times when you have to go ahead and run a for loop, you can also randomize it based on the index numbers. So right now it is also doing in the same manner as it did over here, but just take an idea. So instead of using the elements directly, right now you can also do the for loop based on the index numbers, a custom index number if you want. So instead of going from 0 to 2, 0 to 2, you can go from 2 to 1 or 2 to 0 based on your requirements. Now let's go and see what's next. So next is advanced list operations. So what are advanced list operations? So Python provides powerful built-in functions for common list operations. So finding maximum, minimum values, calculating sums of the list, checking membership, and combining list are the operations you will use frequently in our Python journey. So in machine learning, these operations help with feature scaling, finding outliers, or computing statistics across your dataset. The ability to convert between data structure is also valuable when you need different properties. For example, converting to a set, removes duplicate, a lot of operations you can do over here. So you can use max min, you can use sum of elements, it is going to give you the sum of the elements. You can check membership if any specific element exists in the list or not. You can do list concatenation, merge two lists together by using this concatenator operator. Then you can use replication. You can replicate the existing element of your list. Then you can convert it to other data types. So right now, if your list is a list, if you have to convert that into tuple or set, you can do that too. Now, let's go ahead and understand that with our final examples. So finding max and min values in a numeric list. So our numeric list says 52917. So over here, if I say print max numbers, so it is going to fetch the max number. So max number over here is 9, and 9 has been printed over here. Then I say minimum number. So it has picked 1 and it has done. So this is done automatically. You don't have to write any code. This is an inbuilt method which is provided by Python. Now, sum of all elements. When I say print sum numbers, it is going to sum all the numbers over here available as part of the list, and it is going to give you the total of it. Now, checking membership using in. So when I say print 7 in numbers, what it is going to do is it is going to search for 7, and if it exists, it is going to return a boolean value saying that yes, it exists. But when you say 10 in numbers, it is not available, so it will say false. It does not exist as part of the list. Now, list concatenation. Over here we have created two lists. First list is holding two values, 1 2, second is 3 4. Now when I say use the operator, that is the plus operator, it is going ahead and concatenating the two lists and making it as one combined list. So over here, the combined is equal to list 1 plus 2, it becomes a combined list 1 2 3 4. Replication, repeat the list elements. So right now the list which was created, that is list 1, it was 1 2. Now we have to replicate the elements inside that list, that is 1 and 2 we have to replicate. So it says list 1 into 3, so it has replicated into it in 3 times. So 1 2 1 2 1 2 3 times. That is how replication works. Now converting list to other types. So what you can do is to convert a list to a tuple or list to a set. You can use the inbuilt methods, that is tuple and set. This is going to change. So for example, first I will actually go ahead and print numbers. So if I do this, see over here it is a list. From the brackets you will understand, whenever it comes in a bracket it is a list. Then round brackets, when it is round brackets it is a tuple. So you can see this function has converted the list into a tuple. Then set, then you can see that this this list has been converted into a set with curly braces. So that is how the inbuilt methods work over here. So now coming back, so as I said you before also, make sure you use the official documentation. So Python has all the essential resources where I have just used few of them for the list, the methods that you have seen in the example, but there are a lot of them. So there are common sequences, operation, list comprehensions, and detailed method description with examples. So let me try to go ahead and open it for you. Let's see if it. So this is the official documentation. So right now you will see a lot of methods that we already I was already talking about: append, extend, insert. But these are not, it is not the limitation. There are a lot of methods. Just keep on scrolling down. You will see that there are more methods that you can use. So over here, see, you can use dequeue, pop left, pop right, a lot of methods that I was not able to cover because it's not possible to cover everything as part of the tutorials. But it is your job, if you are onto this journey of machine learning with me, that you refer the official documentation. Okay. Now let me go ahead and come back. So again, I strongly encourage you to explore Python's official documentation as you learn with me, because it's important, because it's the most authoritative source and will help you become a better developer. The documentation for list is comprehensive, as I showed you, and well explained with many examples. So it is not only showing you the methods, it is actually showing you the implementation for that methods too. Now methods too, so you can find it at docs.python.org. Otherwise, the link that I have shown over here, I will share that in the comments below also. You can pick it from there. If you want to get that link immediately, if I forgot by any chance, go ahead and comment asking for link for Python documentation, and I will go ahead and reply to your comment. Additionally, you can access documentation directly in Python using help function also. So there is one help function. When you go to your command prompt and run the help function, it is going to give you a documentation over there. But this is better compared to the output that you get from the help function. So developing the habit of consulting official documentation will serve you well throughout your programming career, especially as you start working with complex AI/ML libraries. So next, so let's summarize what we have covered in this video. So in this video, we have covered Python list, fundamental data structures you will use extensively in AI and ML applications. We have learned how to create, access, modify, and iterate through lists, as well as how to use built-in methods and functions for efficient list manipulation. As you progress in AI journey, you will find this list essentials for representing data sets, feature vectors, prediction results, and more. So in our next video, we will explore more about tuples and sets, which will provide additional ways to store, manipulate the connections of data, each with their own special properties and use case. So thanks everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any questions or thought, feel free to drop them in the comments below, and I would love to hear from you. Remember, programming skill improves with practice. So try to apply these concepts in different contexts to solidify your understanding. Join our WhatsApp community, subscribe to our AI/ML YouTube channel, and sign up for our Tech Insight Neuron newsletter. All these links are available in form of QR code on the screen. You can take it from there, as well as the links are available in the video description too for you. So see you in the next video. Take care and bye for now.